welcome back to Foley Systems. I'm Blake, and today we're talking about RAID. RAID is one of those terms that gets thrown around a lot in the world of storage and servers. But what exactly is it, and why should you care? Whether you're building a home NAS, setting up enterprise storage, or just curious about data redundancy and performance, RAID can make or break your system. In this video, we're breaking down RAID levels, how they work, and which one's right for you. Let's dive in. So RAID stands for Redundant Array of Independent Disk. RAID improves performance by distributing data across multiple hard drives, enhancing read and write speeds. RAID provides data redundancy, ensuring data protection in case of a hard drive failure. In the event of a hard drive failure, RAID systems allow for data recovery, minimizing the risk of data loss. RAID technology was introduced in the late 1980s to enhance data storage capabilities and reliability for users. Various RAID levels have been deployed over the years, each designed to meet specific needs in terms of performance and data protection. As technology advanced, the need for efficient data storage and retrieval led to the evolution of RAID solutions. RAID enhances data reliability by distributing data across multiple drives, protecting against data loss. RAID configurations can improve read and write speeds, resulting in better overall system performance. RAID setups allow for better data accessibility through parallel read/write operations across multiple drives. So let's talk about the types of RAID configurations. Starting with RAID 0, striping. It's speed enhancement. RAID 0 uses data stripping to split data into blocks, distributing it across multiple drives for improved performance. The main advantage of RAID 0 is the significant performance boosts, making it ideal for applications like requiring high-speed data access. Unlike other RAID configurations, RAID 0 does not provide RAID redundancy, meaning data loss occurs if one drive fails. And this is a diagram of RAID 0. As we can see, it just strips the blocks, no parity blocks at all, just 1, 2, 3, and so on. Make sure I get my laser pointer so you guys can see a little better. RAID 1, mirroring, data redundancy. RAID 1 involves duplicating data across 2 or more disks, ensuring that information is safely preserved. With RAID 1, if one disk fell, the remaining disk allowed the system to continue operating without data loss. While RAID 1 provides excellent data protection, it results in reduced storage capacity due to data mirroring. As we can see, drive 1 is the same as drive 2. Even if you had 4 drives, it'll be drive 3 and 4 be the same. RAID 5, stripping with parity, balance of speed, and redundancy. RAID 5 utilizes block level stripping, which distributes data evenly across multiple disks, enhancing performance. RAID 5 incorporates distributed parity, which allows for data recovery in the event of a single disk failure. RAID 5 provides data redundancy, ensuring continuous data access and protection against data loss during a disk failure. This RAID level strikes a balance between high performance and storage efficiency, making it ideal for various applications. As we can see with the RAID 5 diagram, there is a single parity block within each disk. For RAID 5 configuration, a minimum of 3 disks is required. So that means you could lose drive 2, and then the array will build once you insert a new drive. It will take some time for the array to build. But with these parities, it will rebuild that array. But if you lose 2 drives, well, then you have lost all your data. Let's talk about advanced RAID configurations. Starting with RAID 6, stripping with double parity, enhances fault tolerance. RAID 6 provides enhanced data protection with additional parity block, allowing for the survival of 2 disk failures. With the ability to withstand 2 disk failures, RAID 6 is ideal for crucial data storage applications that require high availability. RAID 6 is particularly suitable for environments where data integrity is crucial, such as databases and financial systems. As we can see here with RAID 6, We have 2 parity blocks per drive. RAID 5 reduces your storage capacity as a total quite a bit, with RAID 6 lowering that even more, as RAID 6 requires 2 parity blocks while RAID 5 requires 1. But good benefit of RAID 6 is you can lose drive 1 and 4, or 2 and 3, etc. And put 2 new drives in, your data's all there. But as soon as you lose 3 drives, your data's out. Next RAID level, we're talking about 10, combination of RAID 1 and 0. RAID 0 uses stripping to improve performance by spreading data across multiple disks, what enhances read and write speeds. RAID 1 employs mirroring to provide redundancy by duplicating data on two or more disks, ensuring data protection in the case of a drive failure. RAID 10 combines the benefit of both 0 and 1, resulting in a configuration that offers both high performance and data redundancy. As we see here with the diagram, your 2 disks you have in your system will do a RAID 1. So we'll have a layer 1 is our RAID 1, and then our layer 2 is RAID 0. So we'll just take those 2 RAIDs and strip data across them. Let's talk about RAID 50 and 60, nested RAID levels for high performance. RAID 50 combines the benefits of multiple RAID 5 sets, enhancing performance and data protection through stripping and parity. RAID 60 combines multiple RAID 6 sets for even greater fault tolerance, utilizing double parity for robust data protection. Both RAID 50 and 60 configurations are designed for demanding application, providing high performance and reliable data access. These nested RAID levels offer enhanced fault tolerance, ensuring data integrity even in the case of drive failures. As we can see in 2 diagrams, we'll start with RAID 5 or 50. So it'll take all your RAID 5 sets, as you can see, minimum 3 disks, and it will strip data across all of them. So you could lose a total of 2 drives in a RAID 50 configuration. But in a RAID 60 configuration, that number is quadrupled. As you see, in RAID 6, you could lose 2 drives. Let me back up a RAID 50. I meant to say double. On RAID 60, you could lose a total of 4 drives, because each RAID 6 set will have 2 drives that you could lose. So you could lose disk 1 and 4, 8 and 11, and then replace those disks, and boom, your data is still there. Now let's talk about the importance of RAID in data management. Enhancing data reliability and availability. RAID technology enhances data reliability by storing copies of data across multiple drives for redundancy. With RAID, data remains accessible even if one or more drives fail, minimizing downtime and data loss. RAID configurations improve overall data availability, ensuring that users can access their data whenever needed. RAID configuration allows for data distribution across multiple drives, optimizing storage efficiency and performance. By utilizing multiple drives, RAID systems can dramatically enhance read and write speeds, improving user experience. Improved read and write speeds through RAID configurations lead to better overall system performance and responsiveness. RAID solutions provide a cost-effective way to store a large amount of data, reducing overall storage expenses for businesses. RAID systems allow for seamless scalability, making it easy for businesses to expand their storage capacity as data needs increase. So let's talk about ZFS, Zettabyte File System. Now this is what you use more on a NAS solution. So let's go over it. ZFS utilizes pooled storage to manage and optimize disk space efficiently. This enables dynamic allocation of storage as needed. ZFS ensures data integrity through continuous verification processes. This protects against data corruption and ensures reliability. ZFS offers advanced snapshot features, allowing users to take point-in-time copies of the data simultaneously. This aids in backups and data recovery. ZFS offers advanced disk storage management capabilities. that surpasses traditional RAID systems, enabling better performance and reliability. With ZFS, users experience increased flexibility and efficiency in managing storage compared to traditional conventional RAID setups. Traditional RAID systems often come with limitations such as redundancy issues and complex configurations that ZFS successfully addresses. ZFS offers advanced data protection features such as checksums and snapshots to prevent data corruption and loss. With its user friendly interface, powerful tools, ZFS simplifies the management of data storage systems for administrators. ZFS supports high capacity storage solution, allowing organizations to scale their storage needs efficiently. So this is going to be as ZFS. Um, ZFS does data in pools. So for RAID Z1, as we can see here, it's only one disk that is redundant. But if we do a RAID Z2, we got two disks that are redundant. Now, our conclusion. Importance of RAID. Understanding RAID configuration is key to effective data management and ensuring data availability. Advanced file systems combining RAID with advanced file systems like ZFS can significantly enhance the performance and data integrity. Knowledge of these technologies is crucial for maintaining data integrity and redundancy in storage systems. Now, with the storage solutions I recommend for RAID, if you're going with TrueNAS or NAS solutions that offer ZFS, I would recommend if it's for a home lab and your data is not crucial, let's say photos that are just auto backed up from your phone to that, and your phone still has the physical copy, a RAID Z1 is enough. But if you're going to do a more cloud solution, I recommend a RAID Z2. So that means you could lose two drives before you lose your data. Now, if you're going for a RAID setup, I would recommend RAID 6 if it's highly crucial. But if you could afford RAID 60, that would be my top recommendation. But RAID 6 will be plenty. If you have exactly 6 disks, RAID 6 is what I recommend if you're not caring for total capacity. If you are, RAID 5 I would stick with, as you could lose one disk in your entire system before it goes kaboom. So that's the rundown of on RAID. Whether you're after speed, redundancy, or a mix of both, choosing the right RAID level is key to keeping your data safe and accessible. If you found this helpful, make sure to hit that like button, subscribe for more tech breakdowns, and drop a comment if you have any questions or want to see more deep dives into storage and networking. Thanks for watching Follow Systems. I'll see you in the next one.